Hi students, what I want to do is I want to teach you a little bit about our first packet in straw rocket, varying the rocket length. Now on this, the objective for our straw rockets is to vary the length of a straw rocket to investigate the effect length has on a rocket's range. So in other words, um, we're going to test about different lengths of rockets and see if it makes a difference in how far the rocket can fly. The first thing that you'll notice on your packet is there's vocabulary that you need to put the definitions in. So you'll have to look those up. Um, I should have provided a sheet that you could use to write those in, but you still need to get those completed. Then let me see if I can zoom this in a little bit more. We'll start off with the hypothesis. So engineering the design process. To define a hypothesis, which rocket do you think will travel farther if they both have the same amount of fuel or potential energy? You need to circle one of these two answers. So this is a prediction based on your most educated guess of prior knowledge, anything else, or just what you think. So if they each had the same amount of rocket fuel, let's just say, for example, 200 gallons. So this one had 200 gallons of rocket fuel, this one had 200 gallons of rocket fuel. Which one do you think will travel farther? Go ahead and circle one of those two on your packet. Then you need to explain two reasons why you hypothesize or think your answer will travel farther. So come up with two different reasons. Remember, this is your opinion. This is your hypothesis. I shouldn't say opinion because it's not just a opinion, but it's more using your knowledge to explain what you've learned in your past of which one will fly farther. So go ahead, give a couple reasons on that. Number two, once you're done with that, number two is research. So the teacher will demonstrate the importance of a nose cone by testing a straw rocket without a nose cone. So I can do that right now and give you a little feedback, or a little introduction. So this is our straw rocket launcher. Let me make my screen bigger. Let's see which button it is. Right there. Okay. So this is our rocket launcher, and as you can see, it's kind of hard to. The screen's always so big. We have a plunger that goes up and down, and it's got different numbers on the plunger. The plunger, if I can get closer here, you can see the numbers, and that tells us how high to raise the plunger. So if we drop it, it's a scaled level, and we can have different increments as far as how much force is being applied to this. Now, when it comes down, I'll show you the backside. When it comes down, it's going to push this inside of here and create a pressurized air, a push of air that's going to eventually come out of this tube. This is a brass tube. And we end up putting our straw rockets on that tube. So the pressure is going to push it out and throw that rocket off. However, we need to do some setup before we get to that point. We also have a variable where we can adjust the angle. I had put a box on here so that it keeps it at a set 45 degrees or really close. Try to get it in the camera. Oh, backwards there. So it's close to 45 degrees, and I think it got pushed a little bit there. I have to retape it. There we go. So 45 degrees, so that is a consistent measurement for everyone to use. So with this rocket, we have those different measurements. Now, what we need to do is we need to test this out and see how no nose cone, there's nothing in here, it's just a straight tube, that's got holes on both sides. What happens if I pull up the plunger and drop it? Right there. What happened? So let's go back to the packet. And we can see that without a nose cone, the air traveled where? So you need to answer that question on your brainstorming. Then, if you were to create a rocket based on your prior knowledge of rockets and what they look like, how would you create it? What would it look like? What would a nose cone look like? How about the wings or the fins, as they call them on rockets? What would that look like? So on this, you're going to draw what you have. Now this is for group work. This is for group work. So once you have this, you're going to collaborate with your group or other people, and then you're going to pick the ideas that you want to use from each of your individual pictures, and then create one that you will build together. So with your partner or your group, you decide on the rocket that you want to design and test. Then the next part, we need to build. So to test the different lengths of your straw rockets, we need to control the variables. The only variable that will change in this experiment is the straw length. So for our first rocket, we need to build, we're going to call it Rocket A. We're going to build it using these following guidelines. The first thing is a 20 centimeter straw, which is a full length straw. Then we need to use a small piece of tape to cover one end of the straw. We need about 2 to 5 congruent, that means same size, same shape of fins for each rocket. We're going to plan to make a second set of for rockets. So don't worry about that. We can reuse it, and I'm going to show you how. Then we need a nose cone from a clay ball 1 centimeter in diameter. You will use the same nose cone for each rocket attached to the taped end of the rocket. That's so that we can save it. When we're done testing, so once we build our rocket, we're going to test it. We're going to test it 3 times, get our data, and find a mean of that collected data. Then we're going to come back to our work area and create another rocket that's 15 centimeters. Now it works very easy just to take the nose cone off your previous one, cut 5 centimeters off, and then reattach the nose cone so that you can do the next one at 15 centimeters. We'll repeat the process of testing, collecting data, recording the data, finding the mean, and then we'll come back to the work area and do rocket C, which will be a total length of 10 centimeters. So we're testing 3 different lengths. Rocket A is 20 centimeters, rocket B will be 15 centimeters, and rocket C is 10 centimeters. All right, so here, just to give you an idea of the data that we need to collect, the only variable that we're testing is right here as far as what we are changing. So we're changing length. The other variables will all stay the same so that we can control this experiment. The nose cone will always be 1 gram. The trajectory is 45 degrees, and the plunger force will be 10 on the scale of the plunger. All right, now what I need to do is I need to show you quickly how to set up a straw for this test. So you need a small, it's hard to see on there, but a small piece of tape, and we're going to put it around the top of the nose cone so that it creates a seal, because we don't want the clay to get stuck inside of there. Then let me pull my triple beam scale over here, see if I can show that to you. I got a triple beam scale, and I can adjust the different measurements. And on this one, if I can even get closer here, this is the grams. So I have to grab my clay, or if you're doing this at home or don't have clay, you could use a paper clip or something that has about 1 gram, a real light mass. You could even use just a wad of masking tape if you want. Maybe, I don't know how much, but if I put this on here, my goal is to get it close to here. I'm not going to have to worry about being super picky, just close. That's a little bit big. My clay ball is going to be about 1 centimeter in diameter, or what we say is a very large pea. So let me take off a little bit here and see if I'm closer to the 1 gram. I'm going to help speed it up. And it's bouncing close. It's a tish bit high, but it's really close. So I'm going to go with it. I'm going to go with it. So that's my clay. Put that back. So I have my clay now, and on the taped end of the straw, what I'm going to do is I'm going to flatten this clay out, and I'm going to wrap it around. Now you have a choice if you want to make your cone pointy, if you want to make it square or blunt, or if you want to make it oval. I'm just going to do a little bit of an oval. I'm going to leave a little cushion up there because when it lands onto the ground, it might squish a little bit. So I'm going to leave just a little bit of a padding up on the very tip. Now, that's my nose cone. The next thing I need to do is I need to make congruent fins. And remember, I need you to remember that we're going to cut off 5 centimeters and then another 5. So this straw will be cut in half. So you cannot make fins that are going to be bigger than that halfway point. So we need to make fins that are going to be a little bit smaller, and it's going to be up to you to choose your fins. You can do some research. You can look up some fins. I also have found on, and let's see if I can show this to you. I have found a diagram here where this is from a model rocket building kit. So this rocket model building kit here shows some different size fins and some different designs of them that you could use. You also have to think about how many fins you're going to put on there. Are you going to do 2? 2 is a common one for students to use because that straw is small, so it's kind of hard to get them around. 3, 4. I haven't seen anyone get to the 5 or 6 because that's not a lot of space on a straw. If we had a bigger tube, that might work, but a straw is usually 2, 3, or 4 on the very bottom. Sometimes some people try like a little tiny extra fin on here, and you can do that as well. All right, so I have a couple fins, and I found out that if I put the tape on the fin first, I'm going to try to do 3 fins. So if I put the tape on there first, I want to tape both sides because then it helps it stay up better. So there's 1. So if I try to think of 3, how would 3 go on there? Right about there's my guess. Try to get it to stay up. And let's get my 3rd one on. Close to that. The nice thing about the tape is you can pull it up on a plastic straw and kind of reposition it. See, I just put that one upside down. So we'll reposition it and put tape on both sides so it stays a little bit sturdier. Close. We're close. All right, so I have my rocket, and there's my 3 fins. Not too bad for trying to do this quick. So this is my 20 centimeter rocket. This is rocket A that I will be testing. Now when I test it, I'm going to control those variables. I am going to put it in on the tube, and then we're going to launch it from the rocket launcher here. So this is what we're going to launch 3 times and then test it. Now, once I'm done testing it, what I want to do is I want to pull off the nose cone. And it doesn't matter if I take that tape off or not, but what I need to do is I need to measure down 5 centimeters. In fact, since I have the ruler out, I could measure, so I want to measure down 5 centimeters. Or I can measure up so that because the main thing is that I have 15 centimeters on the rest of this. So I need a 15 centimeter rocket. So I can measure up and get 15. But since I knew my rocket was 20 in the first place, I could just take off 5, but it's more important that we have 15 centimeters up. So then I will take my scissors, I will cut this tube, and then I will retape it, and in fact, I'll just do it right now. So I cut the tube, there's my 5 centimeters I cut off. I need to retape the end. My nose cone is right here. I'm going to put the nose cone back on. And now I have my 15 centimeter rocket. So I will test this again, my 3 times. When I'm done with that, then I'm going to cut it down another 5 centimeters so that I have a 10 centimeter rocket left. And I'll test that. When I'm done with all my testing, I can move on to my next part of the packet, where I need to create a graph based on my mean data. I'm going to create a graph. Remember, to use a best fit line at the end, which has got a prediction line, however it's going to look. Then I need which straw rocket went farther. So based on my data, I need to say, was it the 20 centimeter, 15 centimeter, or 10 centimeter? Explain why you think it went farther. So let's use some details. Remember, try to avoid the word it. Use the correct terminology. Use a vocabulary whenever you can. And just make sure you explain clearly your reasoning. Then you have some other questions here at the back page. Communicate the conclusion. So which rocket traveled farther? I know it's asking that question again. What do you think the length of the rocket affected more, mass or acceleration? Answer here, and then why do you think that? Again, this is an explanation. Avoid the word it and use complete sentences. Explain why. Why? How did the results compare to your hypothesis at the beginning? So you need to go back to your hypothesis, your prediction that you made before you did the testing right here. So when you circled the one here and you explained 2 reasons, how did your initial hypothesis compare to the end result? Were you right? Were you wrong? Were your explanations accurate, or do you think it's something else? So you can answer that here. And then number 8, redesigning. So after testing a rocket, what would you change about the rocket and why? Would you change the fins? Would you change anything else with the design? So this is kind of your chance to answer what you would change. And then going farther or further here, consider the data from all the groups. If you look at the other groups, what relationship do you see between the rocket body length and the distance traveled? So think about the 3 types, compare it to others and yours, and then make an answer here. Then think about this in the real world. So when we say real world in school, we just kind of mean the outside of school world. So this would be important information to a car company because why? Why would companies, when they're designing their cars, want to know why the size of a rocket made a difference? Explain this. Explain this. And what reasons would it help the company so that it would sell more cars? Okay. So this is packet number 1, testing the straw rocket length. Please complete it, and then we'll move on. Once everything is completed in this packet, we'll turn it in, and then we'll move on to packet number 2. And I'll talk about that in the next video. Thank you.